So I'm clicking on go live.
Yes, sir.
Okay, it says the session is live now.
Yeah. Thank you, sir.
Welcome. Okay. So I'm clicking on go live. So shall we get started now?
Yes, sir. We can start, sir. We are on live.
Okay, great. Good evening, everyone. Hope you're all excited as usual. Today is our final day of the training program, day 7 of the training program. So the training program is going to conclude after today's session. And I hope all of you have had a chance to look at the day 7 content on the online portal. And the topics that we are going to talk today are about designing a prototype, building a prototype, testing your prototype with end users, and getting feedback from the end users to refine your prototype. So how many of you have had a chance to look at the portal so far? If you can just put an S, or if you have not looked at it, you can say no also on the chat window. And happy Republic Day. Yes, Sarthak. Yeah, happy Republic Day to all of you. Yes, Mahalakshmi says yes. Okay, that's good. So anybody else? Okay, Hitan Jain says yes. Okay. So only, okay, Muskan, Badrinath, Charan. Okay. Yes. Okay, only a few of you so far. Okay, fantastic. So more is coming now. Okay. So good. If you have already had a look at it and if you have read through the contents, it's good. Even otherwise, I'm going to run you through the contents today, and we will keep the portal open. Don't worry, we will not close the portal right after today's session. Even though the training program concludes, the portal will be open at least till March 6th. And after that, if there is still need, we can definitely keep it open. We can make it more generic rather than ATL Marathon specific. We can broad base it and say this is for to learn the art of problem solving and innovating. It's because it's very generic. It's not necessarily only for ATL Marathon. Okay. So Yeshas says no. Okay. So Yeshas, you can take a look at it later. Many of you have said yes, that's fine, that's good. Anyway, even if you have not looked at it, it's perfectly fine. We will begin today's session and we'll try to conclude early also. I don't want to hold you back for 1.5 hours, 2 hours every day. I'm guilty of that. Okay, and I hope you're able to see the screen that I've shared, day 7 topic.
Yes, sir, we are able to see your screen.
Okay, fantastic. So yeah, let's get started in that case. So what did we do yesterday, day 6? Day 6 was all about ideation and things like that, right? Yesterday, if you remember, day before yesterday, we had come out with a point of view, which was basically a point of view is basically a problem statement, which clearly said what is that problem that we are going to solve. And the problem that we said we are going to solve is minimizing the chalk dust or eliminating the chalk dust in the classroom. And then yesterday, we looked at a lot of solution alternatives, different ways to minimize or eliminate chalk dust in the classroom. We had come out with some 8 different ideas as part of step number 13, I think. And then in step number 14, we narrowed down the number of solutions that we are going to look at by using a prioritization grid. And through that, we plotted a graph of X and Y, where the X represented effectiveness in solving the problem versus cost of the problem. We looked at which are low cost and high cost, which are less effective and more effective. And anything that was less effective in solving the problem, we just removed it and we focused only on the most effective solutions. There were 5 of them. So from 8, we reduced it to 5. And from 5, we used a decision matrix where we evaluated all these 5 solutions on a set of criteria. And do you remember what are those criteria? The 3 or 4 criteria that we used for deciding the best or the most promising solution. What are those? Cost, yes, exactly. Cost is one factor that we looked at. What were the other 3? Effectiveness, yes, perfect. Okay. Any other factors? If you go to day 6, you will find all the answers. So go take a look at day 6 page. You will find all the other. There are two more. What are the other two? Qualities. What is qualities? No, just look at day 6 page. You will find it. What are the other two criteria that we looked at? For shortlisting among those 5 solutions, we evaluated them on 4 parameters. I think ease of use, fantastic. That's correct. Ease of use. How easy is it to use the solution? How expensive or how cheap is the solution? And innovative, fantastic. Exactly. Innovative. How innovative is the solution? So how effective is it? How easy is it to use? How innovative is it? And what is the cost? On these parameters, we evaluated all those 5 solutions, and out of which solution got the highest score? Which among the 5 solutions got the highest score?
Chalk duster.
No,
Vacuum
vacuum
duster.
duster. Vacuum duster. Vacuum duster. How much score did it get?
17.
17. Okay.
17, sir.
Fantastic. That was the highest score, isn't it? And we chose that for prototyping. Whichever idea had, or whichever solution alternative had the highest score, we said we are going to prototype that, isn't it? And finally, what did we do? We selected vacuum duster because that had the highest score. And finally, we elaborated that solution in more detail using solution one pager. What does a solution one pager contain? What does it answer? What are the key questions that the solution one pager answers? Again, that's the last step. Step number 16, right? Name of the solution, that's correct. Problem, what is the problem that we are trying to solve? What are the benefits? Fantastic. What are the problems? Yes, exactly. What else? You missed out one more point. What are the needs? Yes, that's needs, problems are all same. Yes, needs are also part of the problem. There is one more in the solution one pager. If you go to page 6, you'll find what is the solution. That is also correct. Benefits, something else is missing. How is it used? Yes, that is also part of the solution. There's one more point in the solution one pager. Have you all forgotten? Just look at page 6. Who uses it? Exactly, fantastic. Who needs it, or who uses it? The users, basically. Is it for teachers or for students? Is it for parents? So which user is going to use our vacuum duster? For whom are we trying to build the solution? Which users? Isharadhya, you're saying users. Yes, Hitan Jain says teachers.
Teachers.
Teachers. Bhavya Sri says teacher. Okay. Sarthak, is it going to be sold in the market or no? That's going to happen much later, not at this stage. Yeah. So teachers, Venkata Subba Krishna says teachers. Abdul Rahim says teachers. Okay, fantastic. You all got it right. So we built that solution for teachers, not for children. Yeah, maybe sometimes when the teacher is not there in the class, maybe some children or students also might use the blackboard duster. But this is a duster which uses a vacuum principle to clean the chalk dust on the blackboard. The idea is it should not spread too much chalk dust in the air. That was the idea. Now, okay, so we have got the answers. So it's mostly the teachers who are going to use the duster, right? It's mostly the teacher who is going to write on the blackboard, and it's mostly the teachers who are going to erase it. Now let's look at how do we build this. So now we have decided that vacuum duster is the one we are going to build, for which the vacuum duster is a chosen solution. We have chosen vacuum duster because it got the highest score. Now we need to build a prototype to see how it works, whether it really works. We have imagined it so far, saying that, okay, if I put a vacuum mechanism into a duster, maybe it can suck all the dust. And we even assigned it the highest score, but we have not really built it. We really don't know whether it's really going to work or not. Okay, so we need to build it. Okay, that's what we are going to do today. Okay, so we will go through those steps now. Before you build the solution, what should we do? We need to design the solution or design the prototype. Okay, that's what the first step is. So if somebody tells, if you come up with an idea, what will you do first? Will you start immediately like taking some materials and start sticking them together or do something? No, first you think about it, right? You will start thinking about it. You will start, okay, what all materials do I need? And how do I have those materials? Do I need to purchase those materials? Do I have those resource materials in the ATL, or should I buy them from somewhere? Okay, you will make a plan. First of all, you will decide what are the resource materials that are required for building a prototype. Maybe you can even decide sometimes what is the size of the materials that are required. Maybe if you're using some materials, you may, if you have to buy it, you have to even take a measurement for it, right? What is the length, what is the width? Maybe if you want to use some cardboard sheet, you need to cut that cardboard sheet, so that you need to take a scale and measure it and come up with some specification, because you need to know how big the prototype should be or how small the prototype should be. So you need you need to calculate, you need to do some bit of calculations also, because you need to know how much materials you need. So if you are going to build a robo, you need to decide whether the robo will have wheels, and if so, how many wheels will it have? Will it have 1 wheel, 2 wheels, 3 wheels, 4 wheels, or more than 4 wheels? So if you're going to build a drone, maybe you need to find out how many rotors or propellers that the drone is going to have. Will it have 3, 4, 6, whatever, right? So you need to make a list of all the materials that you need, first of all, and only then you will start thinking of what else to do. Okay, so once you have got the resource materials, once you have the specifications, the size and everything, you have worked it out in your mind, then maybe you can start sketching your design also, how the prototype will look like. Okay, so you need to sketch it. You need to sketch it and see how it looks. Maybe how you can even in the sketch, you may just show how it looks, or some sketches may even show how it actually works also. Why you need to do all this exercise? Because resource materials are precious, isn't it? Because they cost you money. If you buy some cardboard sheets, or you buy some wheels or robotic materials, or whatever you buy, everything costs money. So you want to make sure that whatever you're going to buy is not going to go waste. If you don't plan things well, sometimes you may buy some things which are not the right materials for your prototype, and then you may buy this, and then later on you figure out while building that, oh, this is not useful, or this size is small, this size is big, the wheel is too small, the wheel is too big, or this length is less, length is more, whatever. So you might get into all those hassles, and you would have spent some time, you would have spent some effort, you would have spent some money. So to avoid all that waste of time, money and energy and money and everything, you need to plan first. That's exactly what we need to do as part of the design. We need to plan everything. Then finally we will go and build it. So the building effort should be least. If you plan it well, the amount of time it takes to build your prototype will also be very less. Otherwise, if you don't plan and if you just jump into building, you will get something here, something there. Maybe you take some cardboard sheet and you bought it and you paid money for it, and you cut the cardboard sheet in some ways, and then later on you figure out, oh, I made a mistake. And if the cardboard is already cut and you don't have much cardboard, what are you going to do? You'll have to go buy it again. That means you need to spend money again, right? So to avoid all of that, I'm sure all of us are doing this intuitively, right? It's not something that I'm telling you rocket science. You already know these kind of things. So this whole process of innovation is just common sense. It's nothing new. You already know intuitively, you're already doing it. I mean, it's all common sense techniques. All that design thinking does is it takes all this common sense and writes down and gives some name and then fancy name, and you think that you don't know, but actually you already know everything. So you already know everything. It's not at all difficult. Okay, so that's what you do as part of the design. Of course, you can go through some of these videos. It will show you how to do design in different ways. But let me go through some of these pictures and show you what kind of designs you can create. One is the simplest design that you can create is you can create a design on paper. That means you sketch how your prototype should look like. whether it is some car that you're designing, whether it is some house that you're designing, or whether it is some equipment or some machine or anything that you're designing, you write it using a pencil and paper. So you sketch it, draw in the form of a diagram. That's the simplest. We call it as a paper sketch. Okay, that is one way to do it. Another way to do it is you can just buy some simple materials like a thermocol or a cardboard sheet or whatever, and you can create a dummy model, a dummy or a prototype. Just give it some shape so that it may not really work, but we can call it as a design before we build the actual one. So we can use a thermocol and use a knife or something and cut that thermocol into the nice shape so that it gives some appearance. So that also gives some, it will help us with our design. Or we can use a 3D modeling tool or a 3D design tool in which you can create a model in software of how something should look like, whether if it is a spectacles, for example, in this picture on the right, we can create any model that we want in software so that it gives some shape to it, color to it, size, and whatever we want to represent, we can represent it in software. So this is called 3D modeling. Or you might also want to design using, you may want to illustrate your design in the form of a video or using an animation also. There are animation tools like Animaker, which are so simple to use. You can just learn in like 5-10 minutes and you can create animation, and in animation you can represent how your prototype is going to work, or in the scenario in which the prototype is going to work. Maybe you can show a classroom in this animation with a teacher standing there, and then she's using the vacuum duster and things like that, and the students are sitting in front of it. You can represent your design of not just the smart duster, but the entire scenario of the classroom in an animation or even in video also. Or let's say your prototype is about building a mobile app or a web application or something, in which case we can create the designs of the screens. What are the different screens that we are going to create in our mobile app, for example? This is called wireframing or wireframes. Wireframes are nothing but skeletal screen designs, just the bare essentials. Like if we need to have some text input field, we should have a button, we should have a picture, we should have some pop-up menu, pop-up screen, whatever it is. We can just take some mobiles, we can just draw it. Of course, we can sketch this, or we can also use wireframing tools. Software tools are there using which you can design these kind of screens for a mobile app or for a web application. So there are so many different ways in which you can create a design. You actually build it. And why do we design? Because we want to have good clarity before we actually start building it. And the more we can do design, the more detailed our design is, the better or will be our prototype, because we will get more and more clarity as we do more and more design. So the design will cost us less money rather than actually building the prototype, because building the prototype will take us resource materials. But for design, we should use either inexpensive materials like paper and pen or a thermocol or a cardboard sheet, or we should use some free softwares like a 3D modeling tool or an animation or video making tool or a wireframing tool. And without spending any money, we should be able to get good clarity on how our prototype will look like, how a prototype will work. You can, for example, in the mobile app, you can create multiple screens and say, okay, after this screen comes. And if you click this button, then this screen appears. So you can create a series of screens like this. So you do this first, then you are very clear what button, what fields, everything, what picture, what image, everything should be there in this app. And then after that, you can start building the app. Otherwise, if you jump into building the app, then you might not have thought about all the fields that should be part of the screen. And then after you write some code, then you figure out, no, this field should not have been in this screen. It should have been in the previous screen or in the next screen. Then you have to go and change the code. It is going to take you some time and effort, right? It's rework. You're wasting your time in the process. So to avoid all of that, we need to do this simple exercise of wireframing. Likewise, the other ones also. Now let's look at this example of the chalk duster example. In the chalk duster example, we wanted to design the vacuum duster. So as part of the design, first and foremost, we need to identify what are all the materials that are required for building the prototype. Okay, so first and foremost, even before you can sketch your prototype, you need to know what are all the materials that are required. If you remember, day before yesterday, we had this step number 11 and 12, where we looked at existing, we explored some products and services, and we also looked at some of the technologies that are out there, right? Why we did that exercise is because we wanted to know if there are some products or some technologies using which we can build our prototype later on. When we did that exercise, we had identified certain things. Based on that knowledge, we can now come up with a list of materials that are required for building the vacuum duster. Now we have identified 4 resource materials that can be used for building our vacuum duster. One is, we have this small device. It can be electrically operated. It's basically a pump. It's not a water pump, it's an air pump. What it does is, it sucks air from one side like this, from the top. It sucks the air from here, and it takes that air inside and it throws the out air through this nozzle. So there is one inlet, and this is called outlet of the pump. Okay, so it takes the air from one side and it throws the air from the other side. So we can use this mechanism for creating a vacuum cleaning kind of mechanism for our smart duster. And we cannot just put this to the blackboard, right? We need to create a duster. So for that, we are going to use a cardboard box. We are going to attach this vacuum pump to this cardboard box. And on top of this cardboard box, we are going to take this paintbrush, the roller paintbrush. You have seen painters painting walls using this kind of roller brush.
Yes,
You must have seen a lot of painters painting walls of buildings using these kind of brushes. So we remove the handle out of this and we take only this spongy kind of finish. It's soft like material. You can take this and you can use this for creating a kind of a roller effect on top of this cardboard box. And then we'll also use the push button switch, using which we can operate this vacuum pump. Okay, so now we make a list of all the things. What are all the prototyping resource materials we need for creating the vacuum duster? One is portable air suction pump. How many we need? We need just one. How many roller brushes? We are planning to use 2 roller brushes. And we are going to mount these roller brushes on top of this cardboard box. And at the bottom, we are going to attach the pump. And we are going to use one cardboard box, and we are going to use one push button switch. If you press that once, it will switch on. If you press that again, it will switch off. That's how the push button works. These are the 4 resource materials that we are going to use for building our vacuum duster prototype. Okay. Now we have the kind of list of materials that we need. Now let's actually start sketching it and see how the prototype looks like. Okay, this is the diagram of the vacuum duster prototype. This is the design of the vacuum duster. Okay, so basically this is that cardboard box that you saw, and these are all parts of the cardboard box. If you see it from the top, okay, it should look like this. This is the bottom view of the cardboard box. It's a rectangular box. It's the back side view. It's the front side view, and this is left side view and the right side view. Imagine a rectangular cardboard box and you look at it from different directions. How does it look? One side it looks like a square, on the other side it looks like a square. But if you see the other 2 sides, it looks like long rectangles, right? Other 4 sides. And out of those 4 sides, we are going to make a small hole at the bottom, and we are going to attach this vacuum pump. This vacuum pump has an inlet nozzle. We are going to take this nozzle and stick it into this hole at the bottom of this cardboard box. So this is how the finished prototype should look like. So this is the cardboard box, and we have cut open the top, and we have put 2 paintbrush rollers inside it. And in the middle of it, there is a hole. So what we can do is we can insert a rod, so which will act like an axle, and it can rotate. It will rotate these 2 paintbrush rollers. And to the bottom, we attach this vacuum pump. And of course, it has a wire, and you plug it into the electrical socket and it can start working. Okay, if you want to make some changes, you can make it go through this button also. Okay, in this diagram that is not shown, but ideally this wire will go to the button. From the button, the wires will go to the plug point. Okay, so if you see the button is on, if you see the top view, the button is here, and there are two rods. The ones in the black, you can see it here and here. They are the rods that are holding this two roller brushes, and there's half inside and half outside this box. So if you see, the rollers are slightly above. One roller is slightly above, one roller is slightly down. So that is how we are going to mount it inside this cardboard box. Okay, so this is how the design will look like. So is there any question at this stage? Anybody who did not understand how we have designed this vacuum duster using 4 materials? Can you tell me what are the 4 materials that we used to build this cardboard vacuum duster? Can you put it in the chat window?
So Hiten is asking what is the meaning of illustrate?
Illustrate means show, showing it. Design, is this design done in Tinkercad? No, actually, I have used only PowerPoint to do this design. I have not used any Tinkercad. You can definitely use Tinkercad. Tinkercad will give you better appearance, but you can also do this design using just PowerPoint. I have just used PowerPoint to do this design. Okay, so one thing is push button switch, then the air suction pump. Yes, 2 correct answers. Vacuum pump, push buttons, cardboard. Okay, what else? Push button. There are 4 components that we used. Suction pump is correct. Push button is correct. Paint rollers. Yes, paint rollers was also used, and cardboard box. So if you see here, all the answers are here. So these are the 4 components, or the 4 resource materials we used to build the vacuum duster, right? So these are simple things. See, unless you know that there is an air suction pump that is available in the market, you could not have built this prototype, right? And unless you know that there was a paint roller brush available in the market, you could not have built this. And maybe many of you may be familiar with this push button switch, and of course all of you have seen a cardboard box. That's not difficult. These two may be simpler, but if you didn't know air suction pump, probably you could not have built a vacuum cleaner like this, a small vacuum cleaner. This acts like a vacuum cleaner. Okay. And the paint roller brush also you need to be aware of. So basically, if you want to build a prototype, you should even know how to build it. If you come up with a fancy idea of a solution that I'm going to implement, but you don't know how to build it, then it's of totally no use. You have come all the way, you've done all the 16 steps, but the last 4 steps, you will not be able to proceed further because you'll get stuck, because you don't know the technology, you don't know the products that need to be used in order to build the solution. So my suggestion is always make sure that whatever solution that you have selected in step number 16, you should know how to build it. If you don't know how to build it, if you don't know what materials are required, what resource materials are required, what prototyping resource materials are required, don't choose that solution because you will not be able to build it. So I see that's a common mistake many students make. They come up with a solution idea, ultimately, which they don't know how to build it. And if you can't build it, you cannot convert it into an innovation. You have done only research, you have understood the problem well, everything is good, great. But what is the use if you can't build it? So if you have to build it, you should be aware of technologies, tools, products, and solutions available using which you can take some of them and you can arrange them in certain ways, or you can make something, or you can write some program, or you can connect one to the other. And somehow if you juggle with things, if you tinker with certain things, you should be able to build it in a reasonable amount of time. Even if you know how to build it and you have all the materials, but it takes 6 months to do it or 1 year to do it, of course, your ATL Marathon is not going to allow it, because the last date for submitting to ATL Marathon is 6th of March. That means you have little more than a month's time, right? That's all. You don't have much time. So within the short period of time, whatever you can build, you should submit an innovation entry with whatever you can build. Okay. So let me take a few questions. I see a lot of questions popping up in the chat window. Let me go through each of them before we go to the next step. Okay. Let's see. Suction pump. Okay, many of you have answered it. What website should be used for 3D modeling in phone for free? 3D modeling, I don't think there are, I'm not sure if there are very good tools. There are some tools using which you can create some simple 3D models, but I would suggest that you always use a computer or a laptop to create 3D models. Somebody, can you please mute yourself? There's a lot of noise. Okay, yeah, thank you. So don't use any mobile for creating 3D models, preferably use a laptop or a computer. There's a very simple tool called Tinkercad 3D Modeler or Tinkercad Code Blocks. Using these two tools, if you go to tinkercad.com, you'll find both these tools. Both these tools are very simple to use. One requires block programming skills and another is just drag and drop. It's very simple. You can use either of these tools to create very simple 3D models in just a matter of minutes. Okay, but I don't think these tools work on mobile phone. Okay, so work from a laptop or a computer. So that is one answer. Okay, what is the next question? I may not have seen a cardboard box, but I have seen cardboard planes my dad made. Okay, fantastic. I mean, when I say cardboard box, when you buy a new phone, how does the phone come? It comes in a cardboard box, right? So this is as good as a similar box. That's all. It says simple cardboard box like that. It's you can think it of as a cardboard box or a thick box made out of thick paper. We call it as cardboard box generally. But it's made of paper only. Okay, it's not even wood, or you can use a wooden one also, wooden box also. Anything that you can use is fine. But working with a sort of a paper-based cardboard box is easy because it's easy to cut it. If you had to cut wood, you probably had to go to a carpenter and get it done. Cutting wood is a lot more challenging than cutting cardboard boxes. So you can just take a scissors and start cutting it. It's much easier to deal with it. So when this in fact was a solution that was built by a class 7 student, okay, and I had mentored her, and I have just picked up her entire idea for illustrating this. Okay, so and she did it with a simple mobile phone box. She just took a mobile phone box and then she plugged in this pump, air pump, and then that's how she built this vacuum duster. Okay. So any other questions? Paint roll, cardboard. Okay, this have answered. How can we place paint rollers in the cardboard box? Okay, as I said earlier, if you want to mount the paint rollers, if you see the paint roller has a hollow empty inside. It's the outside is the roller, inside it's hollow. Okay, so what I suggest is you can take either a metal or a wooden or a bamboo stick or a pole or a small stick and push it inside this roller and make sure that it comes out of both ends. The stick comes out of both ends, and then you can pierce the sides of the cardboard box so that the stick actually sticks to the sides of the cardboard box and only the rollers rotate inside it. Okay, I hope you are able to imagine what I'm saying. Okay, I can probably show a video of it later on of how it works. If I'll have to look, if I have it, I'll share it on the WhatsApp group. Okay, so you just make it rotate. The two roller brushes, you can make it rotate, and in the center there is a bamboo stick or something. You can buy bamboo sticks in any stationery shop. They're thin, small bamboo sticks that you can buy it, and you can insert it inside this paint roller, and it comes out the other end. And two ends of the bamboo stick, you can stick it to the cardboard box on either side of it. Okay, you need to just pierce it and it comes out. Okay, you can figure out how to do it yourself. Okay. And what is the next question? I'm familiar with many kinds of earphones and smartphones. Okay. What website? Okay, I think you have already answered that. Tinkercad. But it is difficult. Should we prefer MIT App Inventor or Codular for creating apps? I would say both are equally good. Mahalakshmi, yesterday, I think you were asking about the app. So the other one I forgot to name was Codular. So Aditya, thanks Aditya for mentioning this. You can use either MIT App Inventor or you can use Codular, any of these two app builders for building your own mobile apps. Okay. We can add a battery backup to it. Yes, that's a great idea. Yes, you can add a battery backup also to this vacuum duster. I have a doubt related to this session. You said that 3D modeling can be used for designing a prototype. How does 3D modeling work? Okay, if you go to Tinkercad or if you go to the tech skills page, right? If you go here, tech skills page, I'll show you. I have given how to create a 3D model. I've given a complete slide deck on how you can create your own 3D model. So can you see this? Let it load this slide deck. Yeah, so once it loads the slide deck, you can actually go through the slide deck and see this is basically creating a 3D model. And if you go through the steps that are illustrated in this slide deck, you can learn how to create a 3D model yourself. So we're going to write some small block programming and we're going to create, let's see, what are we creating? So we're going to actually create a car in this. So just see this. This is the car that we have created. Okay. So it's a small car, but you can create anything that you want. Okay. So that is how 3D modeling works. You can just drag and drop it and create things. Okay, now I think we have taken a lot of time. I think we covered all the questions. Shall we go to the next step? Or is everybody clear with things? How we design the prototype? First of all, we need to be familiar with what are all the materials that we need. Then we have to make a list of all the materials and how much of quantity is needed. Then we can draw a sketch. And then we can also do the sketch in PowerPoint, or you can use some 3D modeling tool, or you can create an animation, you can create a video. It's up to you how you want to do it. And if you're creating a mobile app or a web application, you can use wireframing tools. So if you see these buttons here, it gives you all the tools. If you click on it, it directly goes to that website. If you click on 3D modeling tool, it goes to tinkercad.com website. See, it goes to Tinkercad website. Okay. So if you go to animation, it goes to animaker.com website. Okay. So similarly for the wireframing tool. And there's a prototyping resource materials chart. So if you go here, you can start filling up all the resource materials that you need for building your prototype first. This is part of your design activity. The first step is to make a list of all the things that you need. Okay. And if you need more rows, you can add more rows and first list down everything. Then you will get an idea of how to, what all materials are required. Then you can start sketching it and then your design is ready. Once your design is ready, then it's time to build it, right? You have to build your prototype or implement the solution. This is the final outcome of everything that you have done. All the primary research, secondary research, defining the point of view, everything, your ideation, everything is finally your designing, everything brings you this step number 18, which is the most important step, because this is what other people can see. People don't see all that work that we have done beforehand. They only see this. And of course, the mistakes that students do is they jump directly to the prototyping step, which is step number 18. Many students skip all the previous steps and directly they jump into prototyping. That means they're skipping all the 17 steps that were required before you start building the solution. So if you don't do any of those previous steps, whatever you build may be completely useless to the users. Okay, so you need to do all that homework before you come to this stage. So finally you design, and finally once the design is ready, then you take that resource materials and you put it together, or you build an app, you write the program, whatever it takes to build the prototype, you build it. Okay, and there are different ways to build it. So there are various types of resource materials. For example, if you have access to a 3D printer in your ATL, you can take that 3D model, give it to the 3D printer, and the 3D printer prints the 3D model in physical world, and it gives you a physical object which can be used as part of your prototype. Or if you want to build some electronics based project involving sensors, actuators, microcontrollers like Arduinos or Raspberry Pi, these are all small computers. If you want to use these kind of things and build your prototype, these resources are available in your ATL. You can use it, or you can also buy it. This doesn't cost you much. Each of these sensors will cost you anywhere from 50 rupees to 100 rupees to 150, 200 rupees. And an Arduino would cost you about 300, 400 rupees. A Raspberry Pi is another microcontroller, a small computer, which will cost you about 2000 rupees. Or you can buy a robotic kit or a drone kit to build your prototype, to build whatever you want. Robotic kits are available for as low as 500 rupees or 400 rupees, and maybe 800 rupees, 1000, 2000, even more. So you decide which kind of robotic kit you want to buy, and you can start building your prototype. So today, nobody builds prototype from scratch. So you need to preferably buy a kit, something like this, and then build your application on it. Whatever solution you're implementing it should be you built using some of these kits or using these microcontrollers, sensors, and actuators. So we are not going to create the sensors ourselves. The sensors are already available. We take it, connect it to this microcontroller, write some program, and boom, it starts working. The prototype starts working. Similarly, if you want to build a robot, of course, you can also build it using these microcontrollers, connect it to a servo motors and wheels, and you can make it, or you can buy a kit and you can also assemble the robot and build it. Okay. Similarly, drone kits are available. You can buy the drones, you can attach the propellers and everything, and you can build a prototype. Or there are other prototyping resource materials also, like screwdrivers, cutting pliers. There are hacksaw blades, or there is soldering a gun, or there is a glue gun. A lot of things are there if you go to an ATL, I'm sure you'll find lots of these kind of prototyping materials. There is Fevicol, there is double-sided glue tapes, there is insulation tape, there is cellophane tape, there are cardboard sheets, there are sketch pens, marker pens, all sorts of prototyping resources are available. You can use any of these prototyping materials to build your prototypes. Or you can use, if you want to build your prototype completely online, for example, if it is a chatbot or a mobile app or a website or some web application or a Python program, then you can use any of the online prototyping tools also. So many of the students in the past, they have attended this digital skilling boot camp, in which we have taught them or exposed them to more than 30 skills in more than 30 digital tools and technologies. And out of which I have given access to about 10 digital skills in this tech skills page here. Okay. So if you want to build online prototypes, go and check out some of these software tools. You can very easily build artificial intelligence based application, or augmented reality, virtual reality, or you can even simulate electronic circuits. A lot of things you can do, create chatbots and things like that. So anything that is built in software, which is either a mobile app or a web-based app, you can create using online prototyping tools. Okay. So there are different ways to build your prototypes. Okay. Either physical prototypes like these, or a virtual prototype or an online prototype like this also, like a chatbot or a mobile app. Now let's look at what kind of prototype was built by this student that I was talking about earlier. She is the one who actually built this vacuum duster. When she started building it, this is how she built it. She took this little big box and then she put one big roller inside it. And it was not that paintbrush roller. She used another big whatever roller, and then she tried to put it inside this and it didn't work and she had to throw it away. And then finally, she learned that there is this vacuum pump, and she got that, and she took this small plastic box. You can see this plastic box here, and she made a small hole at the backside of this plastic box, and she attached this vacuum pump to it. And then on the top, she put this Scotch-Brite pad, and she made a lot of holes in it, and the holes through the plastic also. When you rub it against the blackboard, all the dust goes through these little holes, but it was not very effective. And finally, she built this third prototype with 2 paintbrush rollers and put in a, this is a mobile phone box. And at the bottom, she has attached this pump. And what she does is she holds this whole thing and moves it against the blackboard. And when she moves it against the blackboard, these rollers will pick up all the dust and carry it inside. And when it goes inside, there is this vacuum pump that is switched on, and it starts sucking in all the air. But what happens is, when the vacuum pump sucks all the thing, it may also suck the chalk dust and throw it out. To prevent that, what she has done is she has put a small cloth piece to the mouth of the suction pump. So what happens is, only the air is sucked in, but the chalk powder dust gets stuck to the cloth, and it settles inside, and there is a collection chamber inside this box where all the chalk dust is collected. And later on, she can open this, and she can throw away all the chalk dust that has been collected. And when she actually tried it out, it was probably 60–70% effective in removing the chalk dust from the blackboard. It was still not 100%, but it requires some more improvements. But that is how she progressed, okay, by building these 3 versions of prototypes. Even then, I had requested her to build further prototypes, version 4, version 5, version 6 of the prototype. Okay, so this is how she started building the prototypes. Now, to build these prototypes, you need to acquire certain skills. And in technologies and tools, whether it is technologies that use physical resources or technologies that require online software-based resources. So what I have done is, I have given you 2 buttons here. If you click on acquire skills, it actually takes you to the tech skills page, which this page. So here you can see all the, you can get some skills, you can get some knowledge, or get familiar with some of these emerging digital technologies. And if you want to actually acquire some skills in some digital tools and technologies, for example, if you want to know how to create a video, how to create an animation, how to create a 3D model, you just have to follow these steps in the slide decks. And very easily, you will be able to acquire skills in building a website, or artificial intelligence, or electronic circuits, or how to build a chatbot or a computer program, how to build a mobile app, or an augmented reality experience. So there are 10 skills that you can acquire by going through this page. So that's one thing that you can do before you can start building your prototype. Okay. And the other thing that you can do is, if you click this button, it actually opens up a sheet and shows you the list of all the software tools that you can use, not only for designing, but also for building your prototypes. I mean, all the prototypes, of course, this is only for online prototyping, not for building physical prototypes. For building physical prototypes, of course, you need physical resource materials. But if you want to create a online quiz, or you want to create a music, or you want to create an Alexa-based voice assistant, or you want to create a virtual tour, or a website, or you want to create an ebook, or you want to create a rocket, simulate a rocket, or an animation, or a podcast, a chatbot, or a computer program, 3D model, you want to build a mobile app, or you want to simulate some electronic circuits, build a robot or a drone, there are all the tools that I have mentioned here. So you can click any of these and it directly takes you to that particular website. For example, if you go and click on this and you click this link, it goes to the Animaker website. Okay. So you can just go to any of the website and you can start learning it. And how to learn? For 10 tools, I've already given you step-by-step instructions. And I hope those 10 tools are the most widely used tools, so you can easily acquire skills in building a prototype. Okay, so before I go to the last two steps, which are very simple, let me stop here and take any questions you may have. So let me know first of all whether you have understood the first two steps, design and building a prototype. You can just put an yes or no in the chat box. And if there are any questions, please put a question also. Okay, so everyone is saying yes, yes, I understood. Okay, this is simple and straightforward. This is something that you're most used to. Building a prototype is what most of you are already familiar with. But building online prototypes, virtual prototypes, you have to have skills in certain tools and technologies. Otherwise, you will not be able to build. So the key thing to remember again is you need to acquire skills in specific tools and technologies before you can build your prototype. If you don't have skills in tools and technologies, or if you don't know what products are available out there, you will not be able to build a prototype and you'll get stuck. In spite of doing all the first 16 steps, when you come to step number 17 and 18, you will get stuck because you don't know how to build it. You don't even know whether those technologies exist, whether you don't know whether those kind of products exist. And if you don't know, you're stuck. And many a times I see students making an assumption that, okay, I'm going to use the sensor to make the solution. But finally, when they get to step number 18, they figure out that, oh, that sensor is not there, or that sensor is not available, or that sensor is too expensive, or they don't know how to use that sensor. So what are you going to do? You cannot build it. So at this stage, you should, as you're still in school, you should not try and attempt to build a very complex prototype. You should keep your prototype very simple, like the one I showed you. The building that smart duster, vacuum duster prototype was very simple. All this girl that I was telling you, she did was she took a cardboard box, she took a push button switch, and she took some 2 paint rollers, and she also bought this vacuum pump. So the vacuum pump costed her about 450 rupees on Amazon, and the paint rollers costed about 100 rupees. Or no, it's even less than that. 30 rupees each, 2 paint rollers, 30 rupees and 30 rupees, 60 rupees. Okay, 450 rupees plus another 60 rupees. And the cardboard box was an old mobile phone box. So she didn't have to spend anything. And the push button switch were like one button was costed 10 rupees. So 450 plus another 60 plus 10, how much is that? Okay, so 450 plus 60 is 510 and 520 rupees. So in all, about around 500 rupees, she could build this entire smart duster project. Yes, 520 rupees. So within that amount, she could actually build it and she could actually test it. And she actually, I'll show you, she actually won 50,000 rupees prize money for this innovation she did. Okay. Okay, are there any questions at this stage? I have a question in Tinkercad. Yeah. Only website for 3D modeling, or there are many other 3D modeling tools, but for school students, Tinkercad is very easy and simple to use. There is also a tool called CollabCAD, which is recommended by ATL Innovation Mission. CollabCAD, CollabCAD. That is also a very simple tool. There's no programming required, but it's little difficult to learn. So my suggestion is don't use CollabCAD. There are many other tools. Okay, 3D modeling, there is a Blender and things like that. If you can use it, definitely go ahead and use it. I've seen many students using Blender kind of tools, BLE and DR, Blender. Okay, there are students who are really good in these kind of tools. They have exploded, they have built 3D models. But I wouldn't suggest it to everyone because the learning curve of some of these tools are steep and students get stuck and it takes them a lot more time to learn. And by the time for this marathon will be over. Okay. Sculpt GL. Okay. Sarthak Ghosh is saying Sculpt GL for beginners wanting to get a feel for sculpting in 3D. It's hard to go far wrong with. Okay. Fantastic. Okay. That I'm not sure about this tool. Yeah, Sarthak, if you think this is a good tool, yes, you can even post it in the WhatsApp group so that other students also get to know about this tool. There are many, many tools out there. So you need to figure out for yourself. Tinkercad is one thing I've always found it very simple to use. And Aryan Rai says Blender has a steep learning curve. Okay. Yes, I agree with you. Blender has a steep learning curve. It's not so simple. Jishnu, you're saying, so no need to do 17, 18, 19 step. No, sir. No, if you want to submit your innovation entry for ATL Marathon, you need to go through all the 20 steps, right? Of course, if you don't do it, you can still submit it, no doubt. But an innovation is really going the entire journey, ultimately building the prototype and testing it, and all of that is called innovation. And innovation even involves commercializing and selling it. We are not going to that level at least, but at least you need to build a prototype. Okay. Yeah. So most importantly, to build a prototype, you need to be aware of tools and technologies and products and services available in the market. The more you know, the easier it is to build your prototype. Otherwise, you may make a lot of mistakes. You may build in a way that is not the right way to build it, or it may not be the most effective way to build it. Okay, so Jishnu says my solution is not tech. Okay, fine. If it is not tech, yeah. If prototyping doesn't make sense for your solution, no need to do it. Maybe you can just illustrate it in some other way. Maybe as a storyline, or maybe as a even if you can illustrate it through an animation, that is another good way of illustrating some scenario or something. Okay, so you can create a video of it. That is also, a video can also be like a prototype of, it may just tell the whole story. The video may not exactly demonstrate a product or something or a prototype, but it may tell the entire story. Okay, so you can choose to create a video or an animation, whatever you want to create. So that's entirely your choice. You will know better. Yes, animation can be used. So animation is a good way to represent your story. So that's what you do. Okay, now let's go to the last two steps and we'll try and finish it off soon. Now, when you build a prototype, what are you going to do? Is that the end of the story? No, definitely not. Prototyping is just means that you have brought all your thinking, all your creative potential, all your creative energies, critical thinking, everything that you have done in the previous 17 steps, you have actually brought it into the real world. That means other people can see, you can see for yourself. Maybe it has come into 3 dimensions. In this 3-dimensional world, you can actually show it. Somebody can see it. Maybe they can touch it. If it is a physical product, if it is a virtual product, they can experience it through a mobile app or a website or something, through a computer or from a mobile phone. So you have brought something into the real world. But now, how do you know what you have built is useful to people that you have designed it for? Maybe this vacuum duster was built for the sake of teachers, right? Unless the teachers use it in the classroom, there's no guarantee this prototype really works. Of course, you can test it yourself and see whether it works or not, but you still have to give it to the teacher, because ultimately, if the teacher says this is a good prototype, I want this, and we will buy many more of these, your prototype may not succeed. The teacher should find it convenient to use. It should be comfortable to hold it in hand and use it on the blackboard. The blackboards are really long, and the wire that you have with this vacuum pump should also be really long. If the wire is very short and the plug point is somewhere else in the classroom, you'll not be able to drag this vacuum duster all across the blackboard. So you have a fundamental problem in that it doesn't operate if the wire length is less. So first of all, the wire length has to be really long so that the teacher can move it. And it should not be too heavy also. If the entire vacuum duster is very heavy and the teacher feels pain in her wrist or in her hands or fingers, she will not use it. And it should not make too much of noise. She should not feel that it is making too much of noise, or she should not feel it difficult to use it. It should be smooth. She should be able to, the teacher should be able to smoothly move it across the blackboard, and you should easily clean it. It should not get stuck. It should not have any other problems, right? Or the battery should not run out. Okay, we can make a battery vacuum cleaner, correct, Badrinath? But what if the battery runs out? and then it has to be charged again. In the middle of the class, if the battery runs out, the teacher cannot clean the blackboard. And then again, she has to go back to some wet cloth or a dry cloth or something, and it again creates dust in the classroom. So there are many, many things that we need to really verify. So what we need to do in this at this stage is we need to actually demonstrate. First and foremost step is we need to demonstrate how this prototype works to a few teachers, show them that this works. The second step we can do potentially is we can give a few of our prototypes to the teachers and ask them to use it for a while and tell us how it worked. So basically, as part of your testing activity, you need to really give it to the users and ask them to use it. Okay, when you ask them to use it, they will actually use it and they will tell you whether it worked, it didn't work, whether it worked effectively, it didn't work effectively, or whether it was heavy to hold it, whether the battery ran out, whether the power went out, or whether they could use it across the entire blackboard, or the wire length is less, whatever. All the chances they will tell you. Finally, they will tell you whether it was worth using your prototype or you need to make improvements. So then you need to go back and refine your prototype and make those improvements. Or everything may work out well, but then they may say, oh, just for a duster, you are charging 600 rupees. No, I don't want to spend so much of money. Can you give it for 100 rupees? So what are you going to do? So if people are going asking for 100 rupees or 200 rupees, and if people think that 600 rupees is too expensive for your prototype or for your product, then you need to think of ways and means of bringing down the cost to make it more affordable. Or maybe you need to think of some other way to bring down the cost or make it affordable to people. So you need to think of ways in which you can make it usable by people. Only when you make it usable, people will ultimately buy your innovation and they'll start using it and it becomes a full-fledged product that is sold in the market. Not otherwise. Otherwise, the prototype will just die at death. I mean, you can just give it to a few teachers, they will use it and they'll say, oh, no, all this is not good. We'll go back to our old duster. And if they say that, then it's finished. It's dead. Your prototype is dead. But if you get dissatisfied and you leave it there, that's the end of the story. But if you take it as a challenge and say, okay, I'm going to improve this prototype further, and I'm going to address all their concerns or challenges or requirements, then you have to work again and again and refine or improve the prototype and make sure that it addresses all the needs, whether it is cost or quality or whether effectiveness, whether it is, it can really do the job well. Everything you need to address. So the more and more prototypes you build, the more refinements you can build. And finally, the prototype at one point in time, it becomes ready to sell in the market. At that point in time, it is called as a product. Till that time, it is just a prototype, a better and a better prototype. Okay, that's how it goes on. And finally, when it is really good enough, it may not be the best, but if it is reasonably good enough, that it serves the purpose, then it becomes a product and you can start selling it. Okay, so the ultimate aim of innovation is to sell your product in the market and make money out of it and to add value to people. So if you don't go all the way till there, it is not really an innovation. For ATL Marathon, they don't expect your innovation to be ready to sell, but at least it should go till the prototype stage. Okay, the prototype may not be ready to sell in the market tomorrow. You may still have to do many more prototypes, but at least you need to take it to a level where at least you have built some prototype, having done some research. Okay, so the more detailed research you can do, the better your prototype will be. But even the prototype is not the end. You may have to build multiple prototypes before it becomes ready to sell in the market. Of course, that is outside the scope of ATL Marathon. But if you really want to become a good innovator, you need to build multiple prototypes, take it to a level where it really becomes a product which you can start selling and making money. That is what a real true innovators do. Okay, but as a student, school student, I would say at least build to one prototype or one or two prototypes and you can stop there. If you're really interested, if you're really keen, you can build more prototypes and improve the, give it to the users, let them use it, test it, and give you feedback, and then you can improve the prototype further and further and get it to a stage where it is usable in the usable by end users, and they'll buy it and they pay money to you. So how do we do testing? So I told you two ways. One is first you demonstrate it, and the second thing is you give the prototype and they will test it. But when you do it, you also need to come out with something called as a user test plan. So user test plan is like a design, like how you did the design before you built the prototype. Here again, you need to plan your testing activity. What are you going to test? For whom are you going to give? How long are they going to test it? In which school, which class, how many hours is it going to be used? So you write down a few things like this. Let me show you here. This is basically user test plan. So you make a table and say what is a prototype name? It's a vacuum duster. What is the objective of this user test? To understand whether the vacuum duster prototype meets the needs and expectations of teachers. That's your objective of this testing. Number of prototypes being tested. Maybe you have built 5 prototypes, you want to get it tested. Number of classrooms where the prototype will be tested, you can say 5 or whatever. When will the prototypes be tested? During regular school hours. Where will the prototypes be tested? In class 8, 9, and 10. And what is the duration of the testing activity? 4 weeks or whatever duration that you want to. And what is the success criteria for testing? When do you say testing is successful? Minimize spread of at least 70% of the chalk dust in the classroom. If you can achieve this objective, if you can achieve this result, then your testing is successful. Otherwise, you need to refine and improve your prototype. So you need to make a plan, be very clear about what is the objective of your testing. Okay. So unless you are clear about this, your testing is not clear, and you just give it to some teacher, they'll give you some feedback and you'll not be clear. Okay, so if you want to be very clear, you need to come out with a user test plan before you start testing with teachers or users. And after the testing is done, you create something called as a user test report. Here you actually capture details about what testing was actually done, what was the result of the testing. Where was it tested? You can say government secondary school in Bangalore. Number of prototypes tested 5. Test duration, how long was the testing conducted? For 6 days a week into 4 weeks, the test was conducted by teachers. They used it in the classrooms regularly. What was the test result? User test was partially successful as 3 prototypes worked satisfactorily for 4 weeks in removing 70% of the chalk dust in the classroom, while 2 prototypes broke down during the first week itself. So basically, you're recording what happened during the test. When the teacher started using it, 2 prototypes broke down, it didn't even work. Something went wrong with it, it didn't work. And 3 prototypes worked well. Okay, so you are capturing these details. So this is what you do as part of testing. First, you plan the test, then you actually give it to teachers, let the teachers use it or users use it. And once the teachers use it, you record the details, okay, of what test was done. But this still doesn't take the feedback of the teachers. That's the last step, step number 20 here. In step number 20, we had to ask our users to give formal feedback about how they find our prototype. Was it useful, not useful, and things like that. So why do we need to take feedback? Because the feedback will help us improve our prototype and make it better. So you need to use something called as a feedback form. The feedback form is just another table in which you may have a lot of questions for the user. What is your name? What is your role? This teacher says, I'm Jennifer, I'm a teacher. And you ask a question, did you use a prototype? She says, yes. And how long did you use a prototype? She says, I used it for 2 months now. What is your overall opinion about the prototype? You need to ask a question like this. And she says, the vacuum duster is much better than the regular felt duster I used earlier. And is the prototype effective in addressing your problem? It sucks 70% of the chalk dust from the blackboard and doesn't spread it widely in the classroom. That's what she says. That means it's successful. 70% it removes the chalk dust. Fantastic. What are some of the limitations of the prototype that you have observed? You need to ask this question also to the users. Then they will tell you. Since a vacuum duster operates on battery, it needs to be frequently charged. If it is not charged, it is not useful. That's what the teacher says. When it is not charged, she again has to use the regular duster and it creates dust in the classroom. And you again also ask her what can be improved in the prototype. She says allow the vacuum duster to work from the mains power supply so that it doesn't run out of battery while being used. Maybe she has other feedback also. Maybe she says, extend the length of the wire so that I can clean the entire blackboard, which is very wide in my classroom. The blackboard is probably 6 to 8 feet long, and this wire is only 3 feet long, so I cannot stretch this vacuum duster to the other corner of the blackboard. Okay. Or maybe she says the plug point is far away, or there's no plug point in the classroom, I couldn't even use it. So many challenges. Finally, you ask her, would you buy the solution if it meets your requirements? She says yes. Sometimes users may say no also. They may think that this is not work, this is not good prototype. She may say no. And would you recommend usage of the solution to others? In this case, she's saying yes, but sometimes they may say no also. So you need to gather all this feedback from users, which will give you a sense of how good or bad your prototype is. And if the feedback is not very positive, you need to work further and improve the prototype and refine it and get it to a stage where they can ultimately, you can start selling in the market. Okay. Now, are there any questions at this stage? Anybody has any questions? Did everyone understand, first of all, the testing and the feedback part of it? Steps 19 and 20. If you can say yes, if you understood. If you didn't understand, you can say no. Okay, so I'm getting thumbs up. Yes, okay, fantastic. So this is all simple, I guess, right? Okay, great. Okay, fantastic. So now we have covered all the 20 steps that are involved in innovation. So now all you guys who have attended these sessions in the last 7 days, you know all the 20 steps that are involved. Now you know the art of innovation, you know the art of problem solving, you know the rigor and methodical way of solving the problems. So congratulations, pat your back. You have acquired a great skill in all these 7 days, 1 week. So my congratulations to all of you. So you have learned many new skills. Hopefully, you have learned many tools and techniques, right from user persona to empathy map to observation chart to whatever, right? You have learned many things. You've learned so many tools and techniques. All these tools are downloadable, simple tools. Most of them are simple tables that in which you put some questions and a simple answer. Some of them are like a prioritization grid with X and Y coordinates. An empathy map has multiple boxes in which you start filling information, right? I hope it was fun learning all this kind of different kind of tools. And there are many software tools also available to create empathy map or to create a prioritization grid. So if you want to use it, you're free to go look for these kind of tools and start using it. I didn't want to make it very complex for you. So I just suggested using some simple tools that you can write it on a sheet of paper, or you can download these templates that I have given you. You can just download it in PowerPoint or Word and fill it up. You can do that, or you can use software tools. The software tools are also very much similar to the templates that I have given you. Okay. So no, the site will not close. We will keep the site open. You can come back and refer to this website all the way till March 6th, at least till ATL Marathon is going on, because many of you I know are working on ATL Marathon and you want to submit your entry to ATL Marathon. So it's difficult to digest all this information in just 7 days. I can understand that. And you may still have to go back and refer to this material again and again. So you are free to come back to this website any of these coming days, entire February, March also. And you can read up. If you don't understand, be on the WhatsApp group. Don't leave the WhatsApp group, because if you stay back on the WhatsApp group and if you have any doubt, you can always ask me, and I will always respond to you anytime. Okay. So that way you can still benefit from this. Okay. If we submit entry only, we can submit our prototype. Sorry, I didn't get that question. Can you repeat that again?
Sir, it is if we submit entry, only we can submit our prototype, sir.
Yeah, I mean, submitting an entry involves two things. Submitting an entry involves creating a research document. The research document should contain as many of these 20 steps as possible. If you show them the entire picture of how you arrived at your innovation, that's what your research document should contain. And you should also build a prototype and take a video of your prototype. If it is a physical prototype, you take a mobile phone or some camera and then take a small video of it in all the directions of how your prototype looks like. And if you can also show how it works in that video. If you have built a mobile app or something, you can take some screenshots, or you can take a video of your mobile app working, or chatbot, or whatever it is. If it is an online prototype, you can take a screenshot also, or a screen grab or a screen video, capture the video of your application running on your computer and submit the video. So you need to submit one document and you need to submit a video. Okay. Now coming to the document, there are many ways in which you can write document. I have given you one way to write your document here. Okay, have you seen this slide deck? I'd also shared this in the WhatsApp group, okay, as a link. So if you go here, this has about 22 slides. So vacuum duster innovation, this is a slide deck. You can even probably submit it as a slide deck also. You can just check that whether it should be a Word document, whether it should be a PowerPoint, you can check it. I guess they will allow PowerPoint also. If you see this slide deck, let me open it in full screen mode. And if you see it, it takes you through this entire journey that we covered in the last 7 days. Okay, like if you see here, this was what the first activity we did. Here's what we observed in our classroom. And then you have actually given the scenario here. Each scenario having dust. This is the day 1 or day 3, right? Day 3 we saw this, isn't it? This scenario you all remember. And then we analyzed our observation to come up with several inferences. Then you put up this inference chart here. And then we interviewed a few teachers, students and parents and cleaning staff to validate our assumptions. So the interview questionnaire and their responses is in this table. Okay, so if you just put this, it's very clear. And if you put these kind of headlines, it's very clear for the jury members also that what you have done, how you have gone through this process. And then you say we constructed a few user personas based on the understanding gained. Then what did you do after this? We followed a few students during their entire day to understand the challenges faced by them. And you have shown that in the form of a journey map. And we put ourselves in the shoes of a teacher and a few students to feel the pain they felt from the chalk dust. Here we have captured the experience log. We went to the classroom, acted as if we are teachers. Here is the blackboard, and then we captured the experiences. Similarly, we sat in the classroom, behaved like a student, and then we, when the chalk dust was falling on us, we experienced that also. This is our experience log. And we learned how teachers are dealing with the problem at present and what solutions they're using, right? Solution comparison matrix. And so we compared the pros and cons of the solution. This is basically the solution comparison matrix. So we compare the pros and cons. So if a jury member were to look at what you have created, it's very clear how you're progressing through your innovation journey. They know you have gone through all these details. And you can say we constructed an empathy map to capture our understanding of the problems faced by the users. You show the screenshots of it. We conducted secondary research to understand the impact of chalk dust problem. Then based on all the understanding we gained so far, we articulated the problems faced by the users. We put this POV table. And finally, we came up with a point of view to articulate the problem we wish to solve. What was the point of view? Students, teachers, cleaning staff, and parents need a way to minimize or eliminate chalk dust in the classroom. This is the problem. Because chalk dust causes short-term allergies and poses long-term health hazards. So for this problem statement, we started ideating. Before ideation, we explored a few products and technologies to see if they could be used to build a solution. So we looked at some products, we looked at some technologies. We became familiar with some products and technologies. Then we started ideating. We ideated in a group to come up with various solutions to address the identified problem. We came up with 8 solutions. And we narrowed down those 8 solutions to these 5 solutions which are most effective in solving the problem. So you can say these were the shortlisted ones. After this, what did we do? We then evaluated the shortlisted solution alternatives. We used this decision matrix to identify the most promising solution for prototyping. And this is the most promising, circled one with the highest score. What did we do next? We came up with the solution one pager. We articulated the most promising solution. After this, we came up with a design for the prototype. After this, we actually built the prototype. And finally, we gave the prototype to a few teachers and asked them to use it in their classrooms. What did the teachers tell us? They gave us these feedback. Okay, now if a jury member is looking at your slide deck, he knows exactly what you have done through the entire journey. Okay, he understands the rigor that you have gone through, how detailed you have gone through, and how you have solved this problem. And you can also show certain things. If your prototype was showcased at some competition or innovation competition somewhere else, you can put some photos of those. In this case, this particular girl here, she actually showcased it in a museum in Bangalore. Okay. And these are real photos from her showcase of her prototype at the museum. And then, after this, in fact, her innovation was featured by Times of India newspaper also. This is all real. This is all happened in 2019. So her article came in newspaper. You can see her photo here. And it says class 7 student smart duster can vacuum clean blackboard. They have written an article in Times of India. If you click on this link, it actually goes to Times of India newspaper, and you can see this article here. So if you have done any of these kind of achievements, you need to put that also. So the jury members in the ATL Marathon knows that you have accomplished all of these. And finally, this is the photo in an innovation conclave where this girl won 50,000 rupees as prize money for her innovation. This prize money was given by Parikrama Humanities Foundation. She got 50,000 rupees along with the certificate. So if you have any achievements like this, you should put this also. It proves that your idea was really good and somebody gave you money to work further on your prototype. So this is how you had to project it, whatever your innovation is, all the steps. Okay, so this is one way to do it. So I'm not sure what is the restriction that you have for ATL Marathon. If they say you need to put it only in 300 words, then you need to summarize all this information and just put it in 300 words. But I think that 300 words is only to summarize your information. Whatever document you're going to upload, you need to have a document like this. The research document can be nothing but this. This PowerPoint slide can be a research document that you can submit. There's no 300 word limitation on this document. Whatever you're going to fill it up in the website, on the ATL Marathon website, that may have a 300 word limitation. Otherwise, this document, it's up to you, whatever you write. But it's a very nice way of illustrating all the things that you have done. It very clearly captures all your entire journey, and somebody knows that you have done a very thorough job in solving the problem, right? Do you agree with this? Do you?
Yes, sir. Yes, sir. Yes, sir. We agree with it.
Okay, fantastic. Okay, what about others? What do you think? Would you like to illustrate in all the details?
I have a doubt.
Okay, so fantastic. That's pretty much what I wanted to cover. Again, it has become 1.5 hours today. So there are 2 challenges for you. If you can take this, watch these 2 videos, and you can come up with the design of the water wheel and also fill the feedback form as if you are the user. Similarly, if you can watch this video of the paraplegic person walking with an exoskeleton, and can you come up with the design of the robotic exoskeleton yourself? At least sketch it, how it looks like, and then fill up the feedback form as if you are the person wearing it and walking. How do you feel? Or maybe whatever this guy says, after walking, if he feels good, then maybe you can give that as a feedback. So fill that feedback form, then you will get, you can put yourself in the shoes of the user and feel how the user actually really feels. Okay.
Sir,
Yes.
sir, I'm going to create my solution in an animated video, sir. So
Okay.
in an animated video, first I should show my name and again in which school I've studied, and then I should show that all steps, sir, and then at last I should show how my what is my solution. Like that, I must show in my animation video or how, sir, or directly I can show the my solution as animation.
In your animation video, I mean, is animation video is that your prototype?
No, sir. My solution is not the prototype, sir.
Okay, okay.
It is a solution for clean drinking water.
Okay, if it is a solution for clean drinking water, does it not have a physical or a virtual prototype?
No, sir. Means it is like they can actually go and it taken from, sir. We'll use a vehicle. I'm going to use a truck, sir. And
Okay.
in the truck, if the truck come to the village, and they'll take their pots and they'll inside the truck. They'll go inside truck, and the truck will go to the lake, and then
Okay.
they'll take the water from the lake, and they can go back to their villages. So the
Okay, got it.
Rama can do his farming completely, and she'll get the money also.
Sure, you can create an animation, or you can create a video or an animation video, or you can create a robotic truck also. You can create a robot using ATL resources in the ATL as if it's a truck. You make that robot in such a form that it looks like a truck, or
No,
you
sir,
can create.
it's not an robot, sir. It's like normal truck only. It's an carry truck. They'll sit inside the truck and they'll carry their pots at it.
Okay, okay, sure, anything. So up to you how you want to do it. And if you're creating an animation, you can show the entire scenario in the animation, and that's what the animation should show. Okay, but make sure that your research document goes through all the sequence of steps that I have shown you here in the slide deck. If you can show all the details, then the jury members will be convinced that you have done a thorough job in your innovation. So most of the time students don't show any of these steps. They don't know what, they don't show any of these steps, what they have observed, what they have analyzed, what they have talked to, whom they have talked to, whom they have observed, how did they come up with the problem statement. None of those are shown by students. Most of the time students just show only the prototype. Your research should be shown. That's what the research document is all about. If you show all these details, then it is a thorough research, like it's like a research document, right? All this, whatever work you've done, you have captured in the slide decks. So if you see the prototype slides are only one slide for prototype design, another slide for actual prototype screen, right? Only two are there. Only 2 slides out of total 22 slides, 26 slides or 25 slides, only 2 slides are related to prototype. The rest are all related to other information. So you need to show everything. Okay.
Okay, sir.
Great.
Thank
So
you, sir.
anything else? Anything else? Any other questions?
No, sir.
No, sir. No, sir.
Okay, I hope all of you have followed.
Yes, sir.
Yes, sir.
Very well.
Okay, fantastic. Nice to know that. Yes, any other questions? And somebody else was saying something. So now are you all capable of doing a problem solving in a very methodical way? Yes or no?
Yes, sir.
Can you use all the steps, 20 steps in your problem solving? Okay, or will you just directly jump into an idea and a solution? Will you do that, or will you go through the thorough steps, all the steps?
We'll go to the thorough steps, sir.
Okay, fantastic. Yeah, next time you have to innovate, don't jump directly into 17 or 18 or 19, go through step number 1. Right from observation, you have to go through all the steps. Otherwise, if you directly jump into an idea and you jump into some technology, you don't really know whether your innovation will really fly or not, because you have not really done good homework on understanding the problem. So understanding the problem is very, very important. Okay. Yeah, were there any other questions, or maybe you want to share any feedback about this training program? You can do that also. Please unmute yourself and you can speak.
Actually, sir, so this is Karthik, sir.
Yes.
So sir, ever since I ever since I started so sir, ever since I started attending these sessions, sir, I had liked the I like them straight away because sir, when I when I joined the first session, sir, there were there were some really there were some really actually, sir, these sessions brought back a lot of memories, sir.
Okay.
And I won't and sir, I have one more thing to share, sir. First of all, sir, thanks a lot for thanks a lot for teaching us the for like teaching us the steps of problem solving, sir. We won't we won't forget your explanation, sir. We will
Thank you.
always
Thank you, sir.
and so we will always remember you.
Thank you. Thank you, sir. Thank you. Yeah, and please go ahead and share your knowledge with many more students and groom many more students to become like you now. So that's the only thing that I ask. So whatever knowledge you have gained, you should go and share it with more students. So spread the knowledge. Let's light the fire everywhere. The fire of knowledge.
Sir, in my animation video, I should speak or I don't need to speak, sir. I have to explain the last my solution now.
You can speak in the animation video, or you can even put text like how you see in the cartoon pictures. You can also do that in animation video. You can also put it as text, or you can put your own voice so that as if the character is speaking. So it's up to you. You have to be imaginative and creative in how you create the animation.
Okay, sir. Thank you, sir.
Okay. Anyone else would like to share anything? Any input, suggestions, feedback about this training program so far? Nobody else? Okay. So, or if you want to put it in the chat window also, you can do that. Okay, looks like I don't see any response. So if you are done, if there are no questions, no comments, feedback, suggestions, we can wrap up today's session, and then we are done with this training program. And the only other thing that before you go away, I would like to ask you is click on the share your feedback button on top of this portal, and please leave your feedback. Okay. And then tell me how you find this program and any further support you need in submitting your entry for ATL Marathon. Anything more that you need. Okay, if you want any more mentoring sessions or any other clarifications, how you want me to support you, if you can let me know, I can think of it and see what we can do further. Or if you have some specific suggestions, you can share that also. Okay. Okay. great. Yeah, were there any other questions? I thought Muskan, did you have any questions?
No, sir.
Okay, fantastic. Great. So let's call it a day then. I encourage all of you to go back with this knowledge and start innovating more and more. All the best and good luck everyone who joined this call today. Okay. Thank you very much. It was a great time I had with all of you in the last 1 week.
Yes,
Do stay back on the WhatsApp group. Let's be connected and let's have a great time in the coming weeks as well. Okay, so thank you again for joining.
yes, sir. Thanks a lot, sir. This 1 week was a treasure gaining sessions we had from you, sir. Like a very crystal clear thought process one should do before jumping into conclusions and solutions. That was very well depicted and explained in a very detailed manner for all the students. In the process, even I have gained so much of knowledge from you, sir. That was
Thank you.
really a very fun and practical approach of dealing with the real-time scenarios. Thanks a lot for your time, sir, for allotting to us and encouraging the students and for everything that you have contributed for the enrichment of students. On behalf of Nagarjuna Model School and Air Force School, Habal, I really thank you, sir.
Thank you, Fanindra sir. Thank you very much for your personal support as well as support from the school. And so many students are joining from Nagarjuna Model School, Kadapa. I'm really impressed. And of course, we have students from many other schools also. Thank you, Lilambika ma'am and Principal Renu ma'am from Air Force School, Hebal. They have supported me all through this journey and including this program. And students and teachers from other schools also. Sudha Mishra ma'am, also from Air Force School, Hebal. She has been very supportive of in running this training program. In fact, she's the one who came up with these dates. She suggested these dates to me and said, we'll start from 19th and go up to 26th, and we'll have a break on 23rd. So I just followed her advice. It was amazing journey. So it went as per plan, and I hope it has benefited many students. So again, thank you everyone. So Panindra sir, Lilambika ma'am, Sudha Mishra ma'am, and teachers and parents. Also, I should thank even parents because they have been supporting all our students who are attending. Many a days it's been running from more than 1 hour, like 1.5 hours to 2 hours. And so many of you have been patiently listening in to these programs in spite of it taking more time. So again, thank you very much. Thank you. And so I'll say goodbye right now. But let's be connected on WhatsApp. And in case required, we will have a few more sessions in the month of February, as I said earlier.
Yes, sir, definitely, sir.
Okay, thank you, sir. Thank you.
Yes, sir.
Thank you, Fanindra sir.